Welcome to the FNO InsurTech podcast, a place where movers and shakers from all points within the insurance ecosystem gather and discuss all things InsurTech. We talk about how technology and innovation are affecting and driving change in the industry. Here are your hosts, Lee Boyd and Rob Beller.
Hey, podcast world, welcome to another exciting edition of the one, the only FNO InsurTech. You've listened to all kinds of podcasts, but you've never listened to one like this. Isn't that right, Lee?
That is so true. That is so true. Hey, how great is it to be back? We're back doing another podcast. That's exciting, right?
We're back doing another podcast. And why is that particularly exciting this week, Lee?
Well, because last week we did a podcast in London, England.
The two of us were in London, England.
Our first on-site across the pond podcast, and now we're back over here in the States.
Yes, indeed.
We crossed a big body of water.
Yes, indeed.
How exciting.
We actually did a podcast last week. We went to London. Lee and I went to London. We had business to take care of there for Alacrity, and had a terrific week on the business side.
Yeah.
And got an invitation from Matthew Grant, or extended an invitation to Matthew Grant to have him on our podcast.
Yeah, it was a great time. Great time.
Yeah, and a great podcast that you'll be hearing about real soon. Speaking of secrets, we have an episode with the co-founder and CEO of Leak Sentinel on with us, Bill Loesch. Bill is a longtime Silicon Valley entrepreneur, super successful, even legendary, who has decided to try to conquer a problem that is super hard for a number of different reasons. And that is putting together a leak detection device that addresses all the problems and limitations that there are with those.
And understanding that there's lots of different leak detections out there, right? There's the ones that you put underneath your sink. There's the ones that cut off the pipe. He's out there to see how can he create the perfect leak detection device and water stoppage device. So it'll be a great listen. And
it's an unusual podcast, so we ask that you listen to it and then let us know what you think. This is a different kind of approach to solving a problem than what we usually hear. So instead of getting into detail on it, let's go right to our episode with Bill Loesch, co-founder and CEO at Leak Sentinel. Hey, everybody. We are here with our guest, a special guest coming to us from
Silicon Valley.
Silicon Valley.
Silicon Valley. Where else, Rob?
Yeah.
Well,
it's where innovation happens.
Well, you know as well as I do, Lee, we get people from all over this crazy world.
You are right. We actually don't get very many from Silicon Valley at all.
No, we haven't been in Silicon Valley much lately, but it's great to be back. We are pleased to have with us today from Silicon Valley, as he said, Mr. Bill Loesch, the CEO and co-founder of Leak Sentinel. Welcome to the podcast.
Welcome, Bill.
Thanks for having me.
Bill, was it founder? Single founder?
Well, no, it's a small team.
Okay.
And you want me to start in with sort of how we got there, or you have some more you want to say to begin with? Or
we have what we like to call a self-directed podcast.
Okay,
we do.
So which basically means you do whatever the heck you want to, and we try to keep up. So please jump in with the history. That's always a good place to start.
So I have no background at all in insurance or water or anything like that. Okay. Or even IoT, actually. I'm a serial entrepreneur in Silicon Valley. I have started 4 companies. This is my 5th. 2 of them went public. 1 got sold.
Oh, wow.
And 1 went bankrupt. So, they don't
all. That's a pretty good ratio, man.
A few years ago, I got involved in angel investing in the Silicon Valley. And In 2018, I was approached by a guy who had worked for me for many years at my previous startup. And he was doing some engineering work for a company called Buoy, which I don't know, you may not remember the name, but it was a company that in Santa Cruz that was looking for angel investment. And what they were doing was building a cut the pipe automatic shutoff device. And as you probably know, these cut the pipe automatic shutoff devices all basically are built the same way. They glue together a electrically controlled shutoff valve with
Mm-hmm.
some kind of a flow meter in a box. Okay.
Hmm.
And
Right.
so I looked at it, but when I learned about the cost, I passed on investing because I felt that it was not a mass market. There was really two problems with it. The core cost of the hardware is pretty high,
Right.
and then the fact that you had to have a plumber to install it made it just prohibitively expensive. And
Yeah, like $1,000 plus investment.
yeah, so I thought, well, this is just not going to make it. Interesting. I don't know if this matters to you guys, but Buoy was acquired by Residio. It turned out to be kind of a mediocre investment, so I actually would have made a little money, but Residio wound up shutting it down after a couple of years.
Hmm.
But Buoy's was one of the many cut the pipe solutions out there that I'm sure you guys know about.
Sure.
Yeah, we've had a few on the or at least one on the podcast.
Well, Flow by Moen is
Flow by
most
Moen.
Yeah, sure.
most
Well, that
notable.
was a startup in LA.
Right.
Yeah.
Gabe
So,
Halimi.
After I learned about this space from my old colleague, I got interested in it because I had a couple of water leaks myself. Okay, and I thought, this is a real problem. What could you do about it? And so I started investigating. And what I found is that there are basically two different technologies available, and this goes back to 2018. So this is old data, but interestingly, it hasn't changed. Two different technologies available. One is what I call puddle detectors. Sometimes I call them.
Right.
They're basically little kind of hockey puck things you stick on the floor.
Like
and-
Roost.
Exactly. And if there's a puddle of water, it measures the resistance. And it's basically, what it has is two little electrical probes, and it measures the resistance between the probes, and the water makes the resistance go down. And so it says, okay, water. Okay. So it's
Yeah.
basically a puddle detector. The other solution is the cut the pipe shutoffs that we talked about, where you have a device that is installed on the main water line going into the house, and it's installed by a plumber, and it detects flow or measures flow, and if it sees continuous flow for too long, whatever you define too long to be, it automatically shuts off the water. Okay.
Right.
Now, the individual puddle detectors, as you know, they cost, in this $40 to $50 range, but you need multiple of them to cover a house. How many is not very clear. So that can be, hundreds of dollars. And the cut the pipe shutoffs, typically the device itself costs about $800. And then the plumber's another, somewhere between $600 to $1,000 to install it. So these things are interesting, but one of them, the puddle detectors, isn't very effective in reducing losses.
Why so?
Well, the underlying problem is that you don't know how many detectors you need or where to put them. And in fact, the where to put them is really complicated because it's got to be downhill from wherever the leak is.
Sure.
Right?
I mean,
Right?
if you accidentally put it in a high spot,
yeah, you're screwed.
the water will pool up around it, right?
Yeah. It'll take a while, but until you have like an inch of water, and then you've already
correct. Yeah.
And in fact, years ago when I first started on this, I talked to a guy at HSB who told me about their test home. Okay, they have a at that time anyway, they had a 2-story test home that they deliberately flooded and to test the efficiency of pucks. And he was very, how should I put it, skeptical about pucks as being a very effective way of minimizing leak water loss, because his point fundamentally was that it was so location and number of sensors dependent that it was essentially unpredictable what sort of efficiency you get in any given house, which from the insurer's point of view really isn't very helpful, right? I mean, in one house, you might detect a leak very quickly and it'd be incredibly efficient. And another house and another set of placements, it would be inefficient. And as he pointed out, we had one case where there was like 2 feet of water and it didn't detect it. So that's the underlying problem from the insurer's point of view of how those things work. On the other hand, the cut the pipe solutions are extremely reproducible. It doesn't matter how big the house is or how many bathrooms you have or whatever. If water's flowing continuously for too long, you have a problem. Okay.
Yeah.
You need to shut off the water. All right. So
absolutely.
So that's so I concluded. So then I started looking. So that was the technology.
So you saw an issue with both.
I saw an issue with both, and the issue with the pucks is that they just aren't very efficient in reducing losses, and the issue with the cut the pipe solution is they're very efficient in reducing loss, but they're too expensive. Okay, so the other thing that I did was I went around, I talked to people, did some market research, and I concluded. And, this was my own personal conclusion, but I stated in a very aggressive way. It's obviously exaggerated, but I concluded that there is no consumer demand for water leak products. None.
Which is a big bummer. Big bummer.
I didn't exactly want to go there, but thank you. Thank you. It's seeing that it's not our company, it's yours.
Yeah, but thank you.
I think that you kind of hit one of the various nails right on the head there.
It's just, all these people who think that they're going to sell it to end users, it just never happened. And Flow
Well, it's like, buying meteor hitting your home insurance. Is it in the world of the possible? Yes. Is it hard to relate to? Yes.
Right.
Rob, you just said what I was going to say. From the insurer's perspective, water leaks are a very high incidence problem.
The worst.
Yeah,
right.
Exactly. But from the homeowner's perspective, given the statistics on the incidence of water leaks, I could go for 10 years and have less than a 10% chance of having a water leak. Why am I going to do? Plus, no one ever died in a water leak, and I have insurance.
and there's two groups of people who appreciate it off the bat. Group number one are insurers, and group number two are the people who've had it happen. Right. That relatively that if you say it's 10%, we'll use that number. That 10% of people who've lived through having a flood in their house.
Well, it's probably more than 10% because the incidence rates are like 2% per year. But even there, when you go and you try and sell to somebody who's had a leak, they, oh, yeah. But then you tell them, look, you'd want to spend $1,500 on this problem? No,
my deductible's not that high.
Well, and look, financially, it's not so clear that it's a really good idea. It's really a good idea for the homeowner, because if you have a water leak, of any magnitude, you're going to be into it for your deductible. Okay. And so the thing that a water leak detector does is it cuts off the peaks. That's what a cut the pipe solution does, is it, instead of having, 15,000 gallons of water in your house, you get 1,500 gallons of water. All right.
Right.
And
that makes a difference.
It makes a huge difference to the insurer, but it makes no difference whatsoever to the homeowner from a financial point of view. Okay. Because they still have to pay out their deductible. Okay. because there's some damage, right? I mean, as long as there's some damage, it's usually over the deductible. Okay.
So you see these two existing things, and then what happened?
Yeah. What do you do?
There's an epiphany coming. Yes?
So my conclusion, and this is a classic Silicon Valley entrepreneur conclusion, is that what was needed was a technology innovation that mimicked the functionality of cut the pipe solutions at a tenth the cost. Okay.
Cool.
I mean, if I could deliver what a cut the pipe solution does instead of at $1,500, but at $150, that's pretty interesting. That was my conclusion. Okay, so I set out with a small team of friends and helpers to try to achieve that, and that's what we've done. Okay, so we're in a very simplistic way. What we're doing is we're offering a solution that has the same function as a cut the pipe solution at a much lower cost.
So you mean it'll turn your water off?
Yep.
So, I mean, give us a little insight into that.
Yeah. So how does this work? All right. So, so Leak Sentinel, first of all, we've been working on this for 4 years. This isn't an easy problem. Okay. And we finally have proof of concept. All right. There's been no venture capital investment because the venture capitalists won't invest. All right. Also, I'm tired of venture capitalists, but that's a separate issue. We started obviously with the requirement that a plumber not be required, right? We don't want once you get a plumber involved, there's no way you're going to get the cost down.
It's forget it. That blows it.
So the first thing you have to do is you recognize that every home has a main water shutoff valve by code. Okay, every single home. Okay,
I know where mine is.
Yeah. And so, the question is, could we design a robot to clamp onto that and open and close it? So what we did is we went around, we took pictures of hundreds of real world shutoff valves. All right. And what we found was that plumbers are like modern artists. The pipes go every which way. It's just ridiculous. I mean, you just have
everyone's got to be different.
What were they thinking? In some cases.
Or were they?
Yeah, right. Because in some cases they made the valve deliberately very hard to get at. It's like weird. And in addition, not only are the pipes going every way, but there's all kinds of other devices that are in the line. Best example is pressure regulator that's right next to the valve. So you have this very tough, problem of you can't assume like the pictures you see for some competing shutoff devices, that this valve is neatly located in the middle of 5 feet of straight pipe, okay, on either side. That just doesn't happen. The other thing we did is we did market surveys, and we surveyed a bunch of homeowners, and we found that roughly 50% of homeowners have gate valves, the kind with the wheel on top that you turn a bunch of, 4 or 5 times to open and close.
Yeah.
And the other 50% had ball valves, the kind with a handle that one handle that you turn a quarter turn to open and close.
Yeah, I think that's what I have.
So we concluded that you better be able to handle both kinds of valves, and that was another requirement that we found. And finally, living in California, where we don't have freezing conditions. And so the water comes in outside the house, and typically there's no AC power nearby. So we wanted to have a device that could be either AC powered or battery powered with a rechargeable battery, because we felt that, Texas, Florida, California, these are all places where it's difficult to find AC power near, and all the existing cut the pipe shutoffs require AC power. Okay. So we spent a huge amount of time working on different design approaches, and we tried a whole bunch of different stuff. And we finally came up with something, and it has basically 3 key innovations that make it work in 90% of real world homes. The first innovation is that it supports both ball and gate valves. It has actually a motor shaft, and then it has snap-on adapters to connect to the ball valve and a different adapter for the gate valve.
Time out. And I'm asking seriously, what is a valve and what is a gate valve?
So
Is that the actual thing that you turn?
Yeah. So the valve,
to make the.
There are two basic types of valves, but water valves out there.
Okay. So I mean, that's all we really. Yeah.
Important. Let me explain it.
Okay.
If you just picture this in your mind, the ball valve has this handle, okay, that you turn a quarter turn to shut and a quarter turn to open, and it's a long handle, maybe 3 or 4 inches, just a straight.
Yeah, like a commercial one you might see.
Yeah. Now the gate valves are the ones that have the perforated wheel on the top that you turn, 4 or 5 times to close and open.
Right.
Okay. So it's two. They're two very different types of valves. Internally, they're different, and that the way you actuate them is different. Okay. So that's the difference. Okay. They're very different both internally and the way that you make, the way you open and close them. Okay. Clear?
Perfect.
Yes.
Okay.
Yes.
So that was the first innovation, was to be able to support both with one device. Okay. So
so one device will do either, and they're both quite different.
One device with a little adapter that snaps onto the motor shaft to change, so you put the ball valve adapter on, or you put the gate valve adapter on. Little piece of plastic, basically. The other innovation was that we came up with a single point of attachment that's only 5/8 of an inch wide. So what you need is 5/8 of an inch of round open space that is on either side of the valve, and anywhere from 1.5 inches to 3.5 inches from the center of the valve. So this little tiny round section can be really anywhere next to the valve. All I need is one tiny round section to attach to. All right. And I don't have to be on both sides. I don't have to have a specific distance from the pipe, from the valve to the attachment. So it makes it very flexible. And then I mentioned the battery and AC powered. So those were the 3 main innovations that we came up with for this device. So that took us actually a couple of years, really. I mean, we did a lot of research, a lot of testing of different valves and different sizes and so on. After we had perfected the mechanical design, we then looked at, okay, how do we do flow detection? All right.
Right.
And obviously, if we wanted to stay away from plumbers, we had to use some kind of non-invasive flow detection technology outside the pipe. Okay. There are basically 3 different types of non-invasive flow detection technologies that are in wide use: thermal, acoustic, and ultrasonic. Okay.
Mm-hmm. Right.
After looking at all of them, we found that acoustic offered the best combination of accuracy and low cost. And the acoustic technology is based on the underlying physics that whenever water is at high pressure, your water is at high pressure in your home, whenever it escapes through a shower head, a faucet, a pipe break, whatever, when it escapes to atmospheric pressure, there's a sound that's generated. That's what you hear when you turn on your faucet. And water, as you know, is a very good conductor of sound, and that sound travels throughout the entire pipe system in your home. Okay.
Oh, wow.
And in fact, this technology is not new. Water utility companies have for years been using what they call listening sticks to check leaks in water mains. So this is well known. Okay.
Right.
But a critical benefit of acoustics that we incorporated is that the sensors can be placed inside the same housing as the actuator. So you have one thing to install. Okay, you have this robot that sits on top of the valve, and it not only actuates the valve, but inside the robot are the acoustic sensors that detect whether water is flowing or not. Okay, so that was what we wound up with, and of course that took another couple of years. Okay, that was non-trivial, but we now finally have proof of concept prototypes, and they've been tested by a large insurer and shown to accurately detect flow and automatically shut off the water. So
let's just stop here for a second. So one of the unique things about your company and your process here is that you're not necessarily like holding for those of you who are listening to this, we have the benefit of seeing Bill, and Bill sees us, unfortunately for Bill. And so you're not necessarily trying to sell that device, correct?
Well, we are, but not to the homeowner. Okay. And so that gets to the question of how do we go to market, and so
right. Because right now you're not you're not selling this device today, right?
But first you did a POC and successfully.
Yeah.
And you finally got it. And like you said, these weren't easy, couple of difficult problems here.
Right.
You finally solved them. You have a POC that with a big check mark next to it. So now what?
Yeah. So now what is, as we talked about before, our view is, is that there's no demand for homeowners to buy this. So
you're not going to Home Depot with it.
Right. And our view is this absolutely has to be driven by the insurers, or there is no market. Okay. So if the insurers aren't interested, we wasted our time. Okay. It's that simple. And
I love that thesis. Yeah.
Our view is that it's time for insurers to start mandating these solutions. Now, what do I mean by mandating? It's important to understand that mandating doesn't mean who pays for it. They're two separate questions. Okay.
Mm-hmm.
For example, Chubb and AIG install a cut the pipe water shutoff valve on every home that they insure that experiences a water leak. So they're effectively
after they've had one.
After the leak, as part of their repairing the house. Okay. And so they're effectively mandating it, but they're paying for it. Okay. So that's one way to mandate. All right. And obviously for that approach to make sense, there has to be a positive ROI for the insurer.
Yeah.
Okay. If there's not a positive ROI, you don't do it. Okay. Period. All right.
Right.
And since we are assuming, and I believe correctly, that Chubb and AIG are very smart insurers, we believe that they know that there's a positive
Very
ROI.
smart.
Okay?
Yeah.
But what we did is we went out and we put some simple models together to calculate the theoretical IRR of devices. And we decided to use a benchmark of the 3-year internal rate of return, IRR, it's called. I think you're probably familiar with that. But basically, you want that to be higher than the cost of capital. Okay, if it's higher than the cost of capital, then this is a classic venture capital metric. Okay, so we did some studies, and we did studies that looked at the IRR as a function of the total device cost, and by total cost I mean the cost of the hardware plus the cost of the installation, if it was installed by a professional. And then the effectiveness, which is very simply the overall percentage reduction in dollars, in claims dollars, right? That's all they care about. How much money did I save? Okay. So for example, an 80% effective device means that you reduced your claims dollars by 80%. Okay. similarly 50%, and so on. And then we looked at some of the industry standards. So the industry standard law or average claim for a water leak loss is $12.5K, $12,500, according to the
Sure.
IIR.
Sure.
Okay. Then you could, with that sort of data, you can make some plots. You can look at, what happens. Okay. And what you find is that even if you get an 80% effective device, which is a very highly effective device, they don't have a positive IRR unless they cost less than $300. Okay.
Wow. Okay.
All right.
That's a challenge.
You have to, it has to be low cost. Okay.
That's a challenge.
Now, of course, that raises the question, why are Chubb and AIG paying to install cut the pipe shutoffs? Because they're not stupid. Okay.
No. Right.
And the answer is that Chubb has publicly said that their average water leak claim is $50,000, not 12.5. Okay.
Because of the homes that they tend to.
And there, you can afford to spend $1,500 for a cut the pipe shutoff and have a positive 3-year IRR. Okay. So it's the point is that obviously you want to phase in these, as the costs come down, you phase in the mandates. If you're going to pay for it, you phase in the mandates as a function of the face value of the policy. The more expensive the home, the more expensive the loss, right?
So in an average situation, the average home in America, whatever that is, are you thinking that this is a device that the homeowner installs themselves?
We think that it could be either way. Okay, so one of the advantages,
and the reason that I asked that, and thank you for answering. I'm going to jump in with my follow-up.
Go ahead.
The reason that I asked that is that one of the problems with IoT in general is the follow-through of the homeowner.
People don't install them,
right?
Which has been terrible with water devices.
They get sent to them, and then they sit there.
So we think it could be either way, and then again, it's just financial. You make a financial decision. But let's look at it, okay? We believe that installing our device is roughly the same complexity as installing a Nest thermostat, okay?
Which isn't that easy, but not that hard.
It's not if I take another example, Ting, that's easier. Clearly.
Ting is easy.
All right, I can just plug it into the wall. All right, that's all.
Right.
Connect it.
We actually just had them on the podcast.
Yeah. So, on the other hand, Nest, you got to go back to your furnace, and it's right. There you go. You got one. Okay. So you got there are different levels, but on the other hand, I can go online, and in the Silicon Valley, I can get a Nest thermostat installed for $100.
Sure.
Okay.
Sure.
So one possible approach would be that insurers, take a good example. State Farm made a big investment in ADT. ADT installers could install this and, cost, say, $100. Okay. So if the hardware costs $150, then, you add $100 for install. Now you have a $250 device all in, right? But 100% install, okay, because it was done by a professional. Alternatively, you pay the insurer pays $150, mails it to the user, and only 50% of them get installed, okay? Right. And guess what? You can do the math on that, okay?
Sure.
And it turns out, actually, our math shows that it's probably better to pay the $100 to have somebody install it. But, it's close, all right? So it really is it's a completely financial decision, okay? Whether you do what, the Ting model and you mail it to everybody and, some percentage of them install it, or whether you actually work with a home security company or smart home installer to get the device installed, okay? But that has to be, if you're going to do it that way, you have to roll it into the cost of the device. Okay, when you do your calculation. Now, another strategy. So one strategy is that the insurer pays for it. Okay. And we've talked about that
Right.
at some length.
Right.
And there, it's all about return on investment, ROI,
Yes.
Yeah.
again
Yes.
and again. I keep saying it's
Yes.
all about the money. Okay. The other strategy is that insurers simply mandate it that the homeowner pay for it as a condition of coverage. And in
Right.
fact,
Or maybe they include a 2% discount or something. Right. Some kind of
something of that nature.
incentive,
But in
financial
fact,
incentive.
as an example, I gave the example that Chubb and AIG install cut the pipe shutoffs at their cost. Okay. Another example on the other side is that several months before State Farm left the California market, okay, they actually sent out a letter to all their agents saying, if you want to write a new policy that has a face value more than $2 million, it has to have an automatic shutoff. Okay. So, the homeowner was responsible for going and doing that. So that's an alternative way of doing that. All right. Now, in that case, of course, the insurer isn't putting any money on the line. So it's not a strict IRI calculation, but there is an ROI that you need to think about, which is by definition, not by definition, but you would expect that if you force the homeowner to pay for something, some homeowners may decide not to get their insurance with you. They might go to a different insurer that doesn't require that. Okay, so you may have some defections, right? And you can do some. Of course, it's much more difficult to model that because how do you know how many people are
But
going to defect? Okay,
but you at least you can determine a range of impact. Certainly.
well, and look, here's the other thing that you don't need to have a PhD to know. If something costs $150, you're going to have a hell of a lot less defections than if something costs $1,500. Okay. So, the less expensive it is, the less of a risk you take as an insurer in asking the homeowner to pay for it. Okay. So, either way, either whether the insurer pays for it or whether they ask the homeowner to pay for it, clearly a less expensive device is highly desirable. And that's our whole message is less expensive. Okay.
So you had said to us before we started today that you guys are so let's talk about go to market and give us a quick breakdown of what you're thinking there or how it's going to work.
Well, so our idea is to license this technology to hardware manufacturers. I mean, insurers don't want to get involved in building hardware. Okay. So, our idea is that we would license this technology to hardware manufacturers. And, there's a wide range of possibilities. It could be home security companies, could be people like, Flow, Moen, okay, for example, people that are already making
Right.
pipe solutions. Could be, people like HSB that has a hardware component. They're a reinsurer, so they have this hardware group, Meshify. But there's a wide range of possible hardware manufacturers that could license this technology. All right, and they would be the ones building the technology, and our revenue would come in the form of licensing royalties, not in trying to build devices and sell them and have a gross margin on the hardware. And we think that in order for that to happen, okay, because this is the big risk that we took, that we just don't know. We're all going to find out here in another year or so whether this made sense or not. But the big risk for us is that we've got this horrible, how should I put it, circular firing squad. There's no consumer demand, so nobody is going to license it, right, to sell to consumers. I mean, they know better than that. And there's no insurance demand because the insurers are waiting for a less expensive solution. I mean, Chubb and AIG have, moved forward, but that's a fraction of the market. But, mass market insurers can't do that. It doesn't make sense to them. And even though State Farm did mandate an automatic or started a mandate, in that case, they were asking people to pay, for a flow or something like that. And that's expensive. And there's a lot of risk of people, not being willing to do that.
Mm-hmm.
So we think that the key is that the insurers have to drive this. Okay. And that means, in our view, it means making clear to the market through mandates that there is a demand for this. Then hardware manufacturer would love to license it, right? But if the insurers keep sitting back waiting for the right technology to magically show up, it's never going to happen because, why would anyone put money into this?
Yeah, but this is the right technology, but there's not a tangible product that goes along with it.
Rob, we get this. We talk to insurers and we get this all the time. When can we buy one? All right.
Yeah.
Well, you aren't doing anything to make that happen. What makes you think you should get one? In other words, so who do you think's going to fund that? Mr. Insurer, who do you think is going to pay for that? You think that's going to happen?
Actually, I love this. I love this because it's kind of, this isn't probably a great analogy, but it's kind of like putting a gun to the insurer's head and saying, this is a good idea. It'll pay for itself 1,000 times over. It's easy. There's installation solutions available, but you have to participate.
Yeah, that's the bottom line.
You have to partner with this, or else it doesn't occur.
Yeah.
Right.
And it doesn't take, again, the insurers, many of them have their own venture capital arm. Their own venture capital
CVC.
arm won't invest in this, unless, they're not going to invest in it unless their operating group says you need to.
You have to.
What I mean? There's no money to make this happen. I mean, we put a small amount of money and, some kind of no salary effort into, over a period of time to show that it's technically feasible. All right. Because I think one of the things that's kind of weird is that we're talking about water leak technology that first appeared over 20 years ago. That's an eternity in Silicon Valley. What's wrong with that picture? All right.
Right.
And, the what's wrong with that picture is it's an area that has not gotten any kind of investment to allow innovation.
Yeah.
Innovation doesn't occur without money. It's just, that's the real world. So, I think the reason we're talking to you now is that we want to get the message out that, look, there's something out there that works. There's lots of different ways this could come to the market and you could help us, but you have to step up. You can't keep sitting back saying, well, I'll wait until I can get one and, yada, yada. Yeah, fine. Okay, keep waiting.
I'll tell you what, and this might be a good way that we can get involved as well, and also respect your time today.
Yeah.
How about if we arrange for to get somebody from the carrier side?
Yeah, absolutely.
A smart person, no strings attached, on the podcast and have this discussion.
Love
and
it.
We'll facilitate a discussion between you, or between Leak Sentinel and a representative of the industry,
right?
And facilitate a conversation back and forth. Could be very interesting. It might not be surprising at all, but why don't we say let's do that? What do you think about that, Lee?
I think that's a great idea.
Yeah, we would love to help. I mean, we're at a it's interesting, Bob, with regard to that specifically. Kind of another angle on it is you guys do claims management. Okay, now you're not actually, as I understand it, rolling trucks, right? You basically have a network of people that deal with the problem. But the interesting thing is that another possibility is that the people that, when I had the 2 water leaks, the first call I made was to Service Master. right? Bring in the fans and mop it all up, right? And the sort of the obvious thing is that they install one of these things, right? The insurers could pay them to install it, and they'd love it because, if there is a leak, they could be there before the guy even called.
Right.
Right. So it's kind of there's a whole bunch of different ways that you could take advantage of this. And I don't claim to have all the ideas at all. I'm sure insurers have a lot of better ideas than I have. But I think that, the core proposition that if you take this proven functionality and reduce the cost by a factor of 10, it opens up all kinds of interesting possibilities. And that's what we're seeking to explore. And so I'd love to have that conversation.
Okay. Then we'll pause. We understand you've set the table.
Great.
And we'll have to reach out through our network, which we'll do.
Yeah.
And we'll reconvene for chapter 2 of the Leak Sentinel story.
Super.
Because as you know, and you know all too well, you've been in Silicon Valley your whole career, sometimes you solve a problem that nobody wants to pay for. And you wouldn't be the first one or the last one. But then again, sometimes you solve a problem and you become
the other thing,
a billionaire.
Other thing, Rob, that I've found is that sometimes you solve a problem that nobody cares about. Okay, and that's just that's bad. I mean, that the startup that went bankrupt was a good example of that. Okay, that I did that went bankrupt. All right, it turned out it was a problem nobody wanted to solve in the end. Okay. But the other thing that I think is critical in the success of things like this is the structure of the business relationship. How does it get to market? And that's why I think that it's much better to approach it with a licensing model where you're flexible, because the classic hardware manufacturer, 40% margins, that kind of thing isn't maybe the best way to do this.
Yes. No. And I love that angle to it, right? Because usually it's like, let's build this thing and ship it. But you've built a concept.
Yeah.
And you want to ship that.
Right. Well, the main thing is that we've when we first started here, Rob, the principal objection that we heard was, it won't work. Okay, that was you can't sense the flow from outside. You can't get it to work in lots of homes. Lots of objections. But we've got now something where people can test it themselves and say, yeah, this works.
Cool.
So that's what we put our time and money into, was overcoming the technical objection. Now there's a whole big other issue. Does this make business sense? Okay.
Yeah. Yeah. Well, listen, we'll reconvene, and we'll invite our audience to come back with us on chapter 2.
Great.
And we thank you so much for giving us the time today, and that very interesting story that you have. And I was going to say, we had Ting on, and Ting sent us a Ting.
Right. Yeah.
In fact, that's how Lee got his, by State Farm sent it to him.
Yeah.
So, why can't the same thing happen here? But listen, let's get ready for chapter 2, and that'll happen soon.
Great. Okay. Appreciate the time.
Thank you, man.
Thanks for being on, Bill.
You bet.
A big thanks for Bill and his team for joining us today, and for the explaining a rather unusual concept. I'm sure you'll all agree. Thanks to you for being here, to our production team for making this happen. And until next time, we say
goodbye, everybody.